Angles of elevation and depression. In right-angled trigonometry, we're often asked to manage questions with angles of elevation or angles of depression. Angles of elevation and depression are looking up or down from the horizontal to an object. So when we ask about an angle of depression, it's from the horizontal and it's from the person looking. So this person is looking up, the line of sight there. If this person looked horizontally and then looked up at the person in the hang glider, the angle there is the angle of elevation. The angle of depression is from someone up here looking down. It's again, if this person in the hang glider looked out along the horizontal and then looked down at the person, it's the angle of depression. It touches the horizontal. Angles of elevation and depression are equal. So this angle of elevation, looking up at the hang glider, is the same as this angle of elevation, looking down at the person. You've got to remember they're always from the horizontal. The angle of depression is not from the vertical. It is not here. It's not from the vertical. It's not here. The angle of elevation and depression is from the horizontal. And they make a Z shape. Like that. So two things to learn about angles of elevation and depression. They're from the horizontal and they're equal. Now, we'll often get trig questions with angles of elevation and depression. The steps to follow them are the same. We still need SOHCAHTOA. And if we remember SOHCAHTOA, that lets us remember the three trig ratios. S for sine. Remember there's always theta, and sine theta, S, is O over H. C for cos. Remember theta, the angle, and cos is A over H. And I'm about to run out of space for tan. I'll squeeze it in. T for tan. Don't forget theta, and it's O over A. So if you remember SOHCAHTOA, you can remember from that the three trig ratios, don't forget theta, and having that in front of us lets us solve any trig problem with right angles. Example, to find the height of a tall building, your hull stands 85 meters away from its base and measures the angle of elevation, so we know that's from the horizontal looking to the top of the building. From the base to the top of the building, that angle of elevation is 70 degrees. Find the height of the building. We always assume that buildings and things are vertical, so it's a right angle. If you're ever stuck and you're not sure, just redraw the triangle. 70 degrees there, 85 there, and H, the thing I want to find, is there. But this triangle's pretty obvious. We can just ignore the wall. Solving any trig problem. Label the sides. Now I'm only going to label the sides that have something on them. There's nothing on this side. Angles aren't on a side, they're in an angle. So the hypotenuse has nothing on it. The hypotenuse won't be involved. Here's the angle. So this side that I want to find is the opposite. This side that I know is the adjacent. Label sides, choose and write the ratio. O and A. Which ratio has O and A? It's tan. I write the ratio, including the angle, tan theta equals opposite over adjacent. Substitute my values. I know the angle, it's 70. So I write tan 70 degrees equals, I don't know the opposite, it's got h on it, so we'll call the opposite h over 85. This is where we look at the question and we say, what sort of question is it? X or H? The thing I don't know is on the top. When the thing I don't know is on the top, I'm going to multiply. Remember, I'm going to take this number up to there. So H equals 85 times tan 70 degrees. And when I've got down to H equals or X equals or theta equals, I know I just type this into the calculator. Check that your calculator is in degrees mode, DEG or DEG, or sometimes just D. And we enter exactly what's there, but we don't need the degrees sign. 85 times tan 70. 233.535. Correct to the nearest meter. We're in meters, so that means correct to the nearest whole number. 233.5 rounds up to 236 meters. And because it's a word question, we write a word answer. Therefore, they asked for find the height of the building. The height of the building is 236 meters. So you can see that if we can measure a distance on the bottom and an angle looking up, we can find the height of something that's too tall for us to measure. So trigonometry is useful like that. Another question. A person on flat ground is 50 meters from the base of a pole. The pole is 38 meters high. Calculate the angle of elevation to the top of the pole. Here, I know two sides, but I don't know the angle of elevation, theta. This is a finding an angle question. You'll find that a lot of questions with angles and elevation do tend to use tan. So it's not surprising if a lot of your questions use tan. We follow the steps. Oh, I didn't write my last step. Rearrange and solve with units. So, following the steps. 1. Label the sides. There's the angle we care about. Opposite and adjacent. Which ratio uses O and A? It's tan again. Write the ratio. Include theta. Steps. Substitute the values. Now I don't know the angle, so the angle stays as theta. Tan theta equals opposite is 38 over adjacent is 50. Rearrange. I don't know the angle. When you see that my unknown is the angle, we know we've got to do move the tan sign or cos to the other side. Theta equals tan with the -1. In brackets, the fraction that we've got. And when we've got just the unknown then an equals, that's what gets entered into our calculator. Remembering that the -1 means I'll have to use second function to get the -1, the fraction, 38 over 50, close my bracket, enter, 37.23. When we're measuring angles, we go to the nearest whole number, 37, and it's an angle, so it's 37 degrees. And you would write for a word question, a word answer. They wanted me to find the angle of elevation, therefore the angle of elevation is 37 degrees. So that is angles of elevation and depression, and a reminder of how we use right-angled trigonometry.